All right. Hello, Algebra 2. Lesson is on the law of sines. So we're going to dig into that. So the law of sines has a couple different ratios where if you take the sine of A and divide it by A, it's going to equal the sine of B divided by B and the sine of C divided by C. And again, that also works in the reciprocal, where if you flip-flop the numerator and the denominator, you are going to get the same thing. Again, capital letters are the angles, lowercase letters are the sides. So if we try to look at an example, solve triangle ABC with C equaling 107 degrees, B equals 25 degrees, and side B equals 15. So I would start by drawing it. We might have a triangle that looks something like this. This is not necessarily accurate, but that's 107 degrees. This is 25 degrees. Side B is across from B, so B equals 15. And we are tasked with finding side A, again across from A, and side C across from C. So the first thing I'm going to do is find angle A, which again is pretty easy because I have two angles. So I know that triangles have 180 degrees. So if I do 180 and I subtract 107 and I subtract 25, whatever's left is going to give me my angle, so 48 degrees. So again, looking at what we know, we could use this idea right here to say, hey, I'm going to say that side A over sine of 48 is equal to 15, because I'm given side B, over sine 25 is equal to C over sine 107. So again, if I'm just solving, I'm going to focus on this part if I'm solving A. And then when I'm looking at side C, I'm just going to focus on this part. And it just becomes a proportion at this point. So again, I'm going to say, hey, I'm going to take A over sine 48 equals 15 over sine 25. And this just becomes cross multiplying. So 15 times sine 48 equals sine 25 times A, which means, again, my whole goal is to get A by itself. So what do I need to do? I need to divide both sides by sine of 25 so that this cancels out. So if I plug into my calculator 15 times sine of 48, and then I divide that by sine of 25, I should get A is approximately, because you have to round it, 26, let's call this 26.4. So that's part of my answer. Again, I already found this one right here, so angle A. So A is equal to 48 degrees. That's 1/3 of my answer. Side A is approximately 26.4, and then I'm going to use my second part of my proportion. 15 times sine 107 equals sine 25 times C, which again, if you need to get it by itself, you're going to divide by sine 25, divide by sine 25. So if you take 15 times sine 107, divide it by sine of 25, you should get approximately, C is approximately 33.9. So my three answers, again, I needed three answers, is angle A is 48 degrees, Side A is 26.4 and side C is 33.9. All of this came about by using this, either this proportion or this proportion. You could have done it either way. And again, so this example is oftentimes used with angle, side, or angle, side, angle formulas. Whereas when we get down here, it's side, angle. And so if you remember from geometry, this was one of those weird cases where we said we couldn't always potentially do this. And the reason is because you can get two different answers. Okay, so again, if you look at this, you can have the same angle. You can use the same information, but actually end up getting two different answers because of it. So if we look at this again, this is a side angle. Angle, side. The way Mr. Larson likes to remember it is there's no asses in geometry. Okay, so let's take a look. So we have triangle ABC. And again, the reason I say that is because this has two answers. So anytime you use angle, side, or side, angle, you have to potentially look for that second solution. So we'll do a couple different examples. So solve triangle ABC with A equaling 115 degrees, side A equals 20, and side B equals 11. So always sketch it out, okay? That's the best thing you can do to help yourself understand or see what you're working with. So if we call this A, B, C, this is 115 degrees. Side A we said was equal to 20 and side B was equal to 11. So I'm going to set up my law of sines, which again, sine of the angle over the corresponding side. So I'm going to say sine of B over 11 equals sine of 115 over 20. Cross multiply. 20 times sine B equals sine 115 times 11. Again, how do I get sine B by itself? Divide by 20. Divide by 20. So sine of B is equal to, if I plug into my calculator, sine of 115. So your sine 115 times 11. Make sure you follow parentheses. Divided by 20, I should get about sine of B is approximately 0.4985. And so when I take the inverse of sine at 0.4985, I get an answer of about 29.9. So B is approximately 29.9 degrees. That's going to be one of my answers. Again, you have to get multiple answers for these. So angle B is one of the answers that I needed. The other answer that I needed was to figure out what, once I get two angles, so again, I know that this angle right here is 29.9, so I know there's 180 degrees in a triangle. I'm going to take away 115, I'm going to take away 29.9, and whatever's left is going to give me side C. So 180 minus 115 minus 29.9 is going to give me 35.1. So angle C, so C is 35.1 degrees, which means all I'm left to do is find side C. So side C, again, I'm just going to use my law of sines. C over sine 35.1 equals, I'm going to keep using sine of A and side 20 because I know that it's given. It's usually easier to get, if you have whole numbers, to use what's given to you. So when you cross multiply, you get 20 sine 35.1 equals sine 115 times C. So to get that by itself, I'm going to divide sine 115. I'm going to divide sine 115. So 20 sine 35.1 divided by sine of 115 gives me a side C that is approximately 12.7. So my three answers are B is approximately 29.9 degrees, angle C is 35.1 degrees, and side C is approximately 12.7 degrees. You sometimes, so that was an example of a side-side angle that has only one solution. You will sometimes get a side-side angle that has no solution. So let's take a look at that. So again, this was side-side angle, one solution, side-side angle, no solution. So if we say the triangle ABC, and it has A equal 51 degrees, side A equals 3.5, and then side B is 5. If I look at this, if I were to draw it, I would say, okay, I've got something like this. I've got side A, side C. I know that B equals 5. That was given to me. I know that this is 51 degrees. And then it says that A equals 3.5. However, if I look at my law of sines and I say, okay, well, I need to figure out what this side A is, I would say, hey, 5 times sine of 51 degrees, using my law of sines, that is approximately 3.5. Whereas, or excuse me, that is approximately 3.9. However, my opposite side is only 3.5. So that's where this gap comes in. So because our triangle doesn't meet the requirements, it's one side is not long enough to close the figure. So that's why we say no solution, because the side A is not long enough to create an actual triangle, because 3.5 is not greater than 3.9. So our triangle doesn't close, which means it is not possible to draw this triangle.